Welcome again to those who have just joined about now. Today, it's myself. My name is Risto. I'm the Vice President of Products here at Screening Eagle Technologies. And I have David Corbett, which is part of my team from Screening Eagle, who will actually lead the show today. With you, we're very much looking forward to. Dave, can you switch the slide? Thank you very much. For all of you who don't know us yet, who are the first time and with us, let me give a short background on who we are. So Screening Eagle Technologies, we are based in Switzerland, in Zurich. Beautiful sunny day today. And we have our history in non-destructive technology back since 1954. So we were the first ones who invented the Schmidt hammers. Those who are civil engineers surely should know that product. But 2 years ago, we merged Proceq and DreamLab together under the umbrella of Screening Eagle Technologies. So we have worldwide 8 offices with 3 engineering sites, which is in Switzerland, Singapore, and Spain. The Singaporean and Spanish side more software and robotics focused, while in Switzerland we cover the full range from software, robotics, and sensor development. In terms of our global reach, as you can see, we have our offices across the globe, serving with more than 200 distributors the entire world. We have more than 250 employees by now, increasing almost by the day. We are in strong growth mode at the moment, since a couple of years. And we serve more than 100 different countries. Dave? Good. What is our mission? Our mission is protect the built world. From an infrastructure point of view, this is very, very important. It is our neural network which drives our society and the entire economy. We set out for that mission to be there, the guardians of the infrastructure with different technologies. And we have built new products and continuously building new products to fulfill our mission. And we do that with 2 different elements. Now, Dave, maybe for the next slide, please. With the 3 different elements or 2 different elements, which are advanced sensors. So we need in-depth structural data for measuring really what's going inside, combining that with intelligent software, which will lead us to predictive maintenance to protect the built world. This is in a nutshell about Screening Eagle Technologies. And Dave's mission today is to show you what are the challenges in terms of concrete specifically, and what are solutions to it on how we can protect the built world and enable you to do so. Dave, over to you.
Okay. So thank you, everybody. My name is Dave Corbett. I'm a product manager. I've been working with concrete NDT for many years. And especially in the last couple of years, this has changed radically. And yeah, we'd like to tell you something about that today. So what are exactly the challenges when we talk about inspecting concrete structures? In recent times, there have been quite a number of spectacular, sometimes tragic incidents with structures failing. Primarily, it can be due to birth defects. In other words, problems with the construction itself that weren't picked up, leading to collapse, or aging infrastructure. As all concrete structures, all structures basically are subject to corrosive effects. I mean, we like to talk about concrete cancer. We use an analogy from a human medical structure. So basically something that attacks the concrete over time. And if this is not checked and kept under control, it can lead to this type of event, which we don't really want to see. A big part of this climate change, especially in the US in recent times, I guess more than probably most other countries, you've seen the effects of this extreme heat, extreme cold, storms. All of these things have an effect on concrete. Carbon dioxide is increasing all the time. We know carbonation is one of the key sort of corrosive elements of concrete structures, leading to corrosion of the steel. All of the other things can weaken the structure, can cause cracking, which basically allows corrosive elements to attack the concrete structure. So these are things which actually affect concrete structures more and more. When it comes to maintenance and inspection, quite often inaction is a big problem. It's often just not done, it's ignored. There's also quite often the mentality of repair when broken. So maybe we might see spalling somewhere, so a piece of concrete's broken off, we might patch it, but there's no further investigation to look for the underlying effects, which will almost certainly then lead to more problems in future. So a general lack of preventative maintenance. On the inspection side, the inspections are not always carried out as well as they should be. Quite often it's only a visual inspection. This is not sufficient. I mean, you cannot see everything. It's the same with people. Actually, you look at a person, you can't necessarily see if things are wrong inside them. You need to go deeper if you want to get the full story. Structures, a typical problem is that there aren't any records. There is no birth certificate for the structure, no traceability, no health records. And actually, if you do the inspection, there isn't a unified rating system for structures. So what you do with the results, even if you do a good inspection, if you don't have something similar to compare it with, and this is something that's lacking in the industry. When it comes to carbon dioxide generation, a huge percentage of it is from the built environment. So this is something we all have to be aware of. It's something we all have to take care of moving forward. And if we look at this, if structures are in a state of disrepair, demolishing them and rebuilding them, this is not sustainable. Every time you do this, it has a huge impact on the carbon footprint. If you compare this with the option of doing refurbishing and upgrading, this has a much lower impact on the carbon footprint. So this is something we should be striving for. Inspection procedures, quite outdated, inefficient. There's a lot of fragmented documentation systems out there, not unified, not in one place, and this leads to inefficiency and loss of data. This is coupled with what we call black box NDT. When I started with Proceq, all of our instruments were like this. The data was on the instrument, and if you wanted to share this data with anybody else or back it up, this was a real job to do. It's something that we are moving away from with our technology, which is basically cloud connected and wireless. And this is actually we see the way forward for making sure that this inspection data is not lost. So to summarize this, we're looking at birth defects or a lack of documented quality control, aging infrastructure. A lot of infrastructure around the world now is at the stage where, for example, carbonation layers are starting to reach the steel. This is only going to get worse if we don't look after it now. We have to look at the CO2 impact. I mean, this is very important for mankind as a whole, not just us. We have to move away from paper records. This is very inefficient. It leads to a loss of transparency, a loss of know-how. We have to move away from black box inspection devices to avoid data loss. And generally, actually, this is something, there is a shortage of inspectors as a whole in the industry, and this leads to additional problems. What is not an option is doing nothing. I mean, we've all seen very recently, if we do nothing, there will be failures, and there will be more failures in the near future. I mean, this is a tragic fact, but that is the fact that we're living with. And if we're looking at a building like this one, there was clear evidence of what we call concrete cancer here everywhere. A deeper investigation would have certainly pulled up more information and possibly avoided the issue. So those are the challenges. So how do we go about protecting concrete structures? Well, number one, at the time of construction, we need good quality control. We need to verify that the structure is built as it was designed, and there's actually absolutely no reason why we can't do that nowadays with the NDT instruments we have available. We can check the steel, we can check the concrete quality, we can check everything is as it was specified, and if the workmanship is being carried out properly. And if we do this correctly, this leads to what we call a birth certificate for each structure. So we have reference measurements on the structure, we have the structure documented, and this basically is a blueprint and a reference point for all subsequent inspections during the design life of the structure. It gives us a proper reference point. Visual inspection, condition inspection. This is actually the first part of any inspection, and it remains a critical point of any assessment, a starting point for every inspection. This is combined with checking the vital signs of the structure and for imaging. What do we mean by vital signs? I mean, basically, we can test the strength, we can test the properties of the concrete, we can create heat maps to isolate critical areas, quickly identify these things. The actual quality of the concrete, this is something we consider a vital sign. Going deeper, imaging, we can look inside the concrete. We have the technology nowadays to do this, and we can see a complete picture of the internal structure of the concrete. So here you can see a GPR scan, you can see the rebar structure, you can see deeper lying objects. You should be able to create a picture of exactly what is in this structure. What is necessary? We shouldn't just inspect something when we see visible damage. So when it's too late, it's probably already too late by the time you see that. You should act at an early stage, periodic inspections, and this allows you to do predictive maintenance. If you leave it until it's too late, you can see the costs of actually doing repairs. This increases exponentially, becomes almost prohibitive, and that's another reason why it's quite often not done. So it's very important to start inspections at an earlier stage in the life of the structure. If we do that, then we can move to this type of graph. You can see the structure remains in a healthy state. The repair costs are minimized, and basically the structure should survive its entire design life and possibly even longer. So how do we go about inspecting concrete structures? Again, we use this medical analogy. We're looking at a visual inspection, so a condition assessment. We're talking about vital signs, the actual quality of the concrete, the amount of concrete cover, etc. These are the vital signs. And imaging allows us to see much deeper into a structure to see any hidden problems. Preventative digital inspections, what does that mean? I mean, this is actually a typical life cycle of a structure. So at the end of construction, typically we would do the birth certificate. Again, I've mentioned it before, but it's very important. This gives us a reference point for all subsequent inspections throughout the service life. So it's very important to do these at a regular period. You also have certain events which may trigger another structural inspection. If a new owner purchases the structure, it's in his interest to actually know what he's buying. So at this point, again, there should be a complete structural assessment. If there's some damage to the structure and it needs repairing, you would typically do an assessment before and afterwards to see the repairs being carried out properly. And these are the type of things which should ensure a complete trouble-free, well, as trouble-free as it can be, for the life of the structure. This is a quote actually from one of our main customers in the UK. So Henderson Thomas Associates, they actually a leading structural investigation group. They carry out this type of inspection throughout the UK. And what Warren Thomas says, there is no single technology that would address it all. The multi-technology approach is not an option, it is an absolute must. And this is very true. And this is how we at Screening Eagles basically cover this problem. So visual inspection we do with a tool called Inspect. The vital signs, we have tools like the ResiPod, Schmidt hammer, the Pundit UPV instruments and Impact Echo for testing the vital signs. And imaging, we have a complete portfolio of pulse echo instruments, GPR instruments, eddy current and half cell instruments. So looking in more detail at the things that you have to do, you should be checking for surface defects, cracks. We should be checking for the possibility of corrosion. Concrete cover, the strength together with the concrete cover is typically what's defined by major building codes to guarantee the lifetime of a building. It basically depends how long it takes for corrosive elements like chlorides and carbon dioxide to penetrate to the rebar layer. And we should be looking for internal defects. So these are things that cannot be neglected. We have to do this. When it comes to the visual inspection, we're looking for cracks, so surface cracks. We're looking for the surface condition, and we're looking for visible signs of concrete cancer. So you can see an example of spalling there. The vital signs, basically we can test the strength and the homogeneity of the strength of the concrete, and we can do this with Schmidt hammers, we can do this with UPV, so pulse velocity measurements. In Europe, just very recently, we're allowed to use pulse echo technology for this strength assessment also, which is useful if you only have access to one side. We should check for correct thickness. This is a typical thing in tunnel structures, for example. And we can do spot checks for the rebars, for the cover, and spot checks for the permeability using resistivity, so electrical resistivity measurements. When it comes to imaging, we use 3 different technologies. Basically GPR, you're talking about penetration depth around about 80 centimeters. With the GPR technology that we use, I'll say a little bit more about that later. But for this, we can detect rebars, deeper lying objects, and some defects. With the eddy current technology, we get accurate measurements of the cover. And the same instrument actually we use for a half cell measurement for detecting the state of the corrosion of the rebars. And this we can map out and we can make nice images of it and detect how this progresses over time. With the Pundit array, we can look for deeper lying defects like voids, honeycombing, delaminations, so anything with air inside. And this is these are very important things that you need to see because they affect the structural integrity. This webinar, the purpose is not to go into each of those in a lot of detail of actually how you do a corrosion assessment. I'd like to point you at this time, on our website, we have a place called Inspection Space, and here you can find detailed descriptions of how we do this. There's one there, proformated corrosion. This was the last webinar I did for the USA, where we did went into a lot of detail about how you actually assess the state of corrosion of the rebar network. So very useful place to go and look for more information. So this is the complete Screening Eagle inspection tech platform. You can see visual inspection on the left-hand side with Inspect, vital signs testing with Schmidt, Pundit, and ResiPod, a complete imaging portfolio, GPR, Proformator, and Pundit array. And on the right-hand side, we have something that was launched in May this year. This is actually Workspace, which basically brings all of this together and allows us to make it very efficient. We keep everything in one place. Nothing is lost. It's all backed up on the cloud. And I'll tell you quite a bit more about that a little bit later. So let's look at Inspect in a little bit more detail. This is actually the focal point of any on-site inspection. It's a digital reporting tool for inspectors and engineers. And basically, it allows you to create a complete digital twin of the structure you're inspecting. It allows you to collaborate with colleagues and other teams and basically increase productivity. So we'll have a look at a few more of the functions. A digital twin. Basically, we can import 2D drawings. We can import 3D drawings. We can actually scan the structure and create our own 3D images of it using Inspect, and basically connect this to a geographical location. So it allows us to track what the structure is, where it is, when it was carried out, when any actions were carried out, and who did the inspection. It's got a complete feature set, as you'll see here. So the core functions, as you can see, these are all the type of images, the drawings, so 2D, 3D, geographical maps. You can also add in your own sketches of the structure with your own notes, etc. When it comes to collaboration, we can create reports using Inspect at basically a single click. I mean, this is a huge increase in productivity. You have a dashboard. Each type of defect or object you can classify using your own scheme. So you can get a very quick overview of the health status of your structure. And again, you can talk to people who are actually on site working via Inspect and control who has access to the data. When it comes to the data, you can see here we have completely integration of the Proceq sensors. We have digitization of cracks. I'll say a little bit more about that in future. The 3D scan I've already mentioned. You can actually go and scan the structure using your iPad to recreate a 3D image. And we have a tool for capture, which more basically helps in automating the photographic documentation of the structure. It's all based around what we call a spot. So basically, you precisely identify a particular location, and then at this location, we can basically import any information that we need. So for the inspection, a photograph, quite often you want to record where it is. You can add a sketch if you want. You can write notes. We can directly import NDT data. So if I've done a GPR scan at this particular location, I can import the data here directly. I can access it directly from Inspect. I can use the AI defect to record crack data, and I can import any documents that I wish to this point. So everything is associated with a particular point, all of the information you need. When it comes to crack digitization, this is something which is quite unique. And then it allows us to record cracks. And you can imagine then over time in subsequent inspections, we can compare earlier images with later images. We can see how the cracks developing. And all of this is located on one particular spot. So you know exactly where it is, and you can track the crack development. So this is the full sort of life cycle. Before you even start the inspection, we can set up the asset, we can set up the workflow, who's going to be doing the inspection, who's going to be doing the post-inspection assessment, etc. The field inspection is probably the most critical part. So going on site, doing the inspection, recording where you've done, the measurements, any other information you need. Post-inspection is the data analysis. So a lot of this using the dashboard to basically assess the health status of your structure. And when it comes to reporting, we can generate reports. We can send out reports to maintenance teams, and this is done at the basically a click of a button. So it's a huge time saving on conventional methods. there's no loss of data and everything's in one place. Together with that, we introduced in May this year what we call Workspace, and this basically is a cloud-based system. Everything is in one place. You can see on the left-hand side here, we have all of the information from Inspect, but also from all of the Proceq instruments. So all of the data that you collect are actually backed up on the cloud. They're all accessible in one particular location. It's platform independent, so basically you can access it from any browser, any operating system. This makes it a very flexible solution. Like I said, you have your measurement data directly available. If I've done any scans and saved the shots like that, I can actually see that's a GPR scan on the screen there, for example. I can see this directly in Workspace. This means, of course, actually people sitting back in the office will be able to see data that's being collected on site almost instantaneously. And you can export and you can share this data with colleagues. And this makes collaboration very easy. Like I said, you can access this from any platform. You can export this data, you can download the data, play with it however you wish, and everything's backed up and everything's safe and it's all in one place. It's a huge streamlining effect in the data flow from inspection data to the assessment team, to the people doing out the reports, and also to the asset owners. I'd like to say a little bit more about on the imaging side. It's something we reiterate again and again, but it's very important when it comes to inspection because it's often overlooked. We have uniquely a complete imaging portfolio of technologies. On the left-hand side, you can see our GPR instruments, from the small handheld one up to the new array device we introduced earlier this year. And on the right-hand side, you can see a pulse echo array system. What do we do with these instruments? Well, basically, we can look what's inside the concrete. We can actually map out the rebar structure. We can find deeper lying objects, conduits, tendon ducts, this type of thing. We can measure the thickness of, for example, tunnel walls or slabs or anything. And we can find defects such as voids, honeycombs, and delaminations, things that will affect the structural integrity. Why is it important to use more than one technology here? Well, here you can see we use stepped frequency continuous wave GPR. This is also quite unique. I mean, it gives us an extended penetration depth down to 80 centimeters, but we don't sacrifice the resolution close to the surface for near surface objects. So everything you can see green there, we can see very easily with GPR. We can see the rebar structure. We can see tendon ducts. In some cases, we can see voids, not always, depends on the size. We can't see delaminations with it. If we look with pulsed array, 1 second, you can see we can actually go down to about 2 meters. It depends on the concrete quality, but 2 meters is not unachievable. We can see the back wall echo from very thick objects. We can see delaminations. It doesn't matter how thin a crack is, we can detect this with pulse echo. We can see voids and honeycombing. So anything with a large air content is what we can see with pulse echo. So you only get the full picture of the internal structure when you combine the results from both instruments. You can see here now almost everything's in green. There were still some problems. If I have a deep a delamination or a void quite deep in the concrete, I will not be able to see beyond it. Some objects will be shadowed by both delaminations and steel, but generally we can get a very, very good picture of what's inside the concrete when we combine these two technologies, and that is very important to know. Here you can see typical scans. So on the left-hand side, GPR, we can see the rebar structure very clearly. We can see the back wall is partly shadowed by the rebars. What we don't see very well are cracks and delaminations. On the left-hand side, you can see a pulse echo scan where we can see deep lying cracks. We can see larger objects like post-tendon ducts, and I'll say a bit more about that in the next section. And we can see honeycomb, voids, etc. We don't see the rebars so well. Well, we can see them, but it's much more efficient to scan this with GPR technology. And something else which is more or less unique to us, we use augmented reality. Any of these large data scans that we do, you can project them directly onto the surface of the structure. I mean, this is useful for if you're marking out, for example, coring positions. It's also useful for explaining your NDT inspection results to people who are not NDT specialists. I guess, you know, these pictures in the middle, you can show those to anybody. They would understand that that's the rebar structure and there's a large conduit going along the right-hand side there. So it makes it useful for explaining to lay people. I'd like to mention grouting defects in post-tensioning systems. If you're looking back at the original introduction to the challenges, a lot of the structural failures were bridges, and a lot of bridges are coming to the time in their lifespan where, for carbonation layers are reaching the tendon duct level, etc. So this is something that really is of concern worldwide. A tendon duct basically looks like this. You can see where we may have grouting defects here. Basically, if there's no grout there, there's nothing to protect the steel strands, and then they're much more at risk of corrosion. And this is something that we need to be able to identify. We have a recommended procedure for doing this, and it's not just our procedure. This is a procedure which is actually in use. It's being used successfully by various customers of ours around the world. So basically, we can map out the rebar structure with GPR. We can map out the tendon duct to see where it's running very quickly. GPR is a very fast scanning technique. Once you've done that, you can scan the tendon duct with the pundit array. What the pundit array does is allow you to detect anomalies. You get very weak reflections if it's fully grouted, because the ultrasonic signal just passes straight through it. If there's a grouting defect and there's air inside, basically you'll get a very strong reflection, and you should be able to detect this. It's not 100%, it's not infallible, so it's always recommended to verify these anomalies by doing targeted drilling and checking with a bore scope. Previously, customers who were doing this type of inspection, they would just drill blindly into the tendon duct, and maybe they detect anomaly, maybe they don't. This technique allows them to do this with much more precision. They can target really where they want to drill. They can check if there's a grouting defect where it's expected according to the scans, and this saves a lot of time and gives much better results. This is an example from the UK, one of the early examples. So, and you can see here the scans from a grouted section and an ungrouted. You can see the weak echo from the grouted section, very strong echo from the ungrouted section. So this one, in this case, a very clear example. And when they opened it up, you can see this is confirmation of the results. On the left-hand side, there's clear grouting missing there, and on the right-hand side, it's fully grouted. A similar topic is looking for voids in the anchor zone of post-tensioning systems. This is another key application. And again, we recommend to test this with ultrasound pulse echo. And again, if there are no voids there, we will get weak reflections. But if there are voids present, which will affect the structural stability, affect the anchoring, then this will show up as strong echoes. And here you can see an example of a real scan on the left-hand side with voids present, and on the right-hand side, what you would expect if there were no voids. So again, very clear results, and virtually no other technology will give you this kind of indication. So to sum this all up, we look at our inspection ecosystem. So you can see this allows us, it's a holistic system. Everything's included, everything's integrated. There is no loss of data. There's full traceability, which allows us to make the comparisons we need through the lifetime of the structure. So from the sensors to the inspection system and to the software you need to assess it, it's all in one system. And what we recommend is to establish this 3-pillar structural assessment. So first of all, you should have a review of the documents, if there are documents available. For new structures, there should be. For quite a lot of existing structures, there aren't, and this is the problem. We need to do a visual inspection. This is the starting point also. We should identify cracks, signs of concrete cancer, so spalling or rust stains, this type of thing. And absolutely necessary, we need to do NDT testing to get the full picture, so we can check the strength, and not just in 1 or 2 locations. Like with coring, we do comprehensive strength testing, which you can do very quickly with NDT. We can check the permeability, we can check the cover, we can check for things like carbonation, and we can look for internal structural defects. And what we really recommend is actually to establish some kind of a unified reporting system. This should all be digitized. Otherwise, there will be a loss of data. There will be a loss of know-how transfer. So you need to keep this in one unified system. A unified rating system. This is something very few places in the world have actually tried to implement this, but we see this as the way forward. It's based on having a birth certificate for new structures and combined with a standardized asset rating. Once we've done our assessment, it should be easily to compare with the asset rating system to define if it's fit for purpose or if it's at risk, you know. So this should be quickly identifiable, but it requires a rating system. And you can only do this if you can compare similar structures. So again, in order to implement this, you need a maintenance plan. We've seen we need to do maintenance starting at an early stage in the life of the structure and periodically. We need to do an assessment, which is both visual and NDT. A visual inspection is not enough. And we need to carry out repairs if necessary. That's also going to happen during the life of the concrete structure. And all of this should be recorded, and it should be recorded in one location, so we have complete know-how transfer and records for the future. So this is a summary. We need NDT testing. Visual inspections is not enough. We need a unified recording system. We need to be able to keep everything in one place for the lifetime of the structure. We need to have asset ratings so we can easily identify if an action is necessary or not. We need to implement this idea of a birth certificate so we have a reference to compare with as the structure moves forward. And we need to digitize workflows. This fragmented use of paper and black box tools and basically is going to lead to data loss. And the only way to make this efficient is to digitize the workflows. As a last slide, I'd like to make everyone aware there's a Proceq USA special event being planned. You can see on the 5th of October in Miami. And basically, you will see the product demonstrations. You will see technical presentations in more detail than we've gone into now. Get your hands on the equipment, have a look at inspect, see how easy it is to use and how useful it can be to your structure. And with that, I think that's the end of the webinar. So if anybody has any questions, we would be happy to try and answer them. Thank you very much.